Hello students, welcome to Lab 7. If you're still here, that means you're a graduate student, and we have now entered the second part of this course, where we're going to move on from the R programming language and get you a little bit more exposed to Python. Before we jump into that, I want to make a couple of notes about R versus Python and a lot of those other sorts of arguments you may have already heard about or have strong feelings about, or sure enough you'll hear about pretty soon. There seem to be among newer data scientists or folks who come from the software engineering world a lot of strong feelings about which programming language is better to use on a day-to-day basis, R or Python. Having used both for quite some time and having used both in a professional aspect, I can tell you that both of these languages have their strengths and they have their drawbacks. So far, we've done R because I believe R has a more cohesive package and library for doing data analysis and manipulation. There's a reason we start with dplyr, and that's because the underlying concepts, I believe, really are state of the art. It's really easy once you get your head wrapped around the basic ideas to expand your application of tools to situations that you're maybe unfamiliar with. Tidy data is a really strong concept, and R does a really good job of implementing that. R also does a very good job of using the grammar of graphics in its implementation of ggplot. ggplot, and we're going to continue to use ggplot, albeit in a different form in Python, but ggplot is a really outstanding visualization package that gives you a remarkable amount of freedom along with a consistent set of rules that can help you predict what your code is going to do and build the types of visualizations that you want. So those are the types of things that R is really good at, and that's why we started by using R. Because in analysis, I believe it's important for you to understand how to do those two things first before you jump into other things. Now, if you came to analysis from Python, there's obviously nothing wrong with that whatsoever. But if I get to organize a class, I'm going to put R first. That being said, Python is undoubtedly better at some other things. For example, there really is no comparison between R and Python when it comes to the machine learning workflow. Python has the scikit-learn library, and really all of modern data science is built around a Python environment. You're using pandas to analyze your data, you're using scikit-learn to fit your models, or you're using PyTorch or TensorFlow to fit neural networks and other things of that sort. So a lot of what Python really excels at is these types of engineering tasks on the back end, like once you've built your model, for example, getting it productionalized and putting it out into the world or into your company so that it can be used by other people. R has those tools as well, but they're maybe not quite as developed. R is outstanding at having all kinds of very cool statistical models. It's very good at having matching tools for causal inference and other things like that. Python is not very good at that. Python is very good at machine learning stuff. R has those tools, but maybe they're not as developed as Python is. So all of that to say is really the lesson I want you to take away from this is not to be too dogmatic about what language you like and what language you're a real booster for, a real cheerleader for. Good analysts and data scientists, generally speaking, keep an open mind so that they can try new tools when they present themselves and identify what's good about those tools that they can take forward with them. Now, truthfully, it's unlikely that Python will continue to be the language that every single data scientist uses forever for the next, let's say, 40, 50 years of your career, right? There was a time when it seemed like R or Python could become the lingua franca of data science, and Python pretty much won that contest, although R has still a sizable following. So all of that to be said, it's totally fine to like one more than the other, no problem, but try not to be too dogmatic about it. Great. So let's start in Python. As we did in R, of course, we need to download Python itself. Why don't we go ahead and download Python? And you'll notice that we're going to download Python versus version 3.13.7. So we're going to go ahead and get that started. And we're also going to download Visual Studio Code. Just as RStudio is an IDE for R, VS Code is kind of a general purpose IDE. You can really write any sort of code that you want in VS Code. Now you might ask, why are we bothering to download another IDE? Because the clever among you may have noticed that in fact, we can write Python code in RStudio. And to make this point, why don't we open up RStudio here for a second and I can show you that that's possible. No, we're not going to write any Python code yet. So we're going to open up a new file and we will see that, here we go, Python script. Sure enough, right? You'll notice that the little symbol in the corner is no longer the R symbol, instead it's the Python symbol. And if I start writing Python code, it'll highlight it as it does for R properly. So RStudio can be used to write Python code, but we're not going to use it for that purpose today. We're going to use Visual Studio Code for that reason that I mentioned earlier. What I'd really like for you guys to do is to become familiar with multiple different languages. So here's Visual Studio Code. Went ahead and we just opened this. Let me close this for a second, make sure that my Python installation worked. Yep, looks like we're good. So we downloaded Python, we downloaded VS Code. So why don't we go ahead and why don't we open up Visual Studio Code? And here we are. Here's your landing page for VS Code. This is your IDE just like RStudio is. And we're going to want to start a new file. That's a Python file. And you'll notice that we have two options here. I'd like you to pick the IPyNotebook version. And I want to take a minute and I want to talk about what it means to work in an IPyNotebook. You'll notice that I get a cell, and these are called cells right here that open up. And each cell can input code. So in Python, when we want to import a library, we don't use the library function. We just say import pandas, and then we want to name that library for now. This will make a little bit more sense later, but stick with me for a second. We're going to say import pandas as PD. And when I hit enter or control enter to run that cell, you'll notice it asks me to select a kernel. And what it's asking me when it tells me that is it's saying, what programming language do you want to use to run this code? And since I just opened it up, since I just downloaded Python, it isn't quite aware that Python exists yet. So we're going to browse the marketplace. Now, we're going to need the Jupyter Notebook extension. So why don't we go ahead and restart that? And let's see how that goes. Alrighty, so I went to the Python environment and I want to click on Python. That's fine. So it looks like we need another package so that we can run IPyNotebooks. No problem there. We're going to go ahead and run all of that. Our IPyNotebook has loaded Python. Our kernel, meaning the language that it's using to interpret the code that I write, is going to be that version of Python that I just downloaded. And I ran this cell meaning one chunk of discrete code. So I did import, which is the same as saying library in R. And then I said the name of the package, which is pandas. I'm going to say as PD. PD you can think of as like a nickname for this library. And it'll become more apparent why we do that going forward. But for now, just take this structure as it is. This is how we import packages in R. You'll notice when I ran this that it says no module name pandas. This error should seem feel relatively familiar because it's a similar error to what we got when we try to call a library in R that either isn't downloaded, or maybe we misspelled it, or something along that nature. So how do we address this? Well, we need to install that package. Notice that I inserted another cell into my notebook here. Now, what goes into a cell is kind of a matter of taste, but generally speaking, you want to put each new idea of your code in a new cell. This is an IPy notebook. So a notebook is just a collection of different cells. Now, when I hit enter, when I hit execute code, it'll run everything in this cell. But for now, all I really want to do is install pandas. And I can do that by saying pip install pandas. And I'm going to hit that. I'm going to let that run for a second. And pandas is quite a large package, so it might take a couple minutes, but it's working, so that's fine. One of the benefits of using notebooks, as opposed to using a flat R script, as we did when we were using R in RStudio, is that you can interweave your exposition and your code together. So for example, whenever you were writing your R code, you would perhaps write a comment that would say, hey, the code underneath does XYZ thing. And then you would write some ggplot code, for example, and then it would print out your visualization in the viewer panel in RStudio. Now, RStudio is particularly well suited to writing R code because visualization is a really important aspect of writing R code. So it pops up those visualizations, but in a sense, you kind of have to follow that raw code one after another. That's not a particularly pleasant way of doing things. Instead, if we organize our code into cells, what happens instead is that we can do a couple of things, like, for example, now that our install is done, I'm going to go ahead and I'm going to put this here, and I'm going to comment it out, and I'm going to say install and load libraries. Just going to run that. Now pandas has loaded. We'll see later on the benefits of doing this, and I'm going to also import plot9. Actually, there are multiple ways of loading. Let me get rid of this cell for a second so that it clutters things up, or doesn't clutter things up. There are multiple ways of loading packages in Python. Another way to load all of the functions in a package is to say from plot9 import star. Again, we get that error that there's no module named plot9. So why don't we go ahead and pip install plot9. This says all of the different functions that are a part of plot9, I want you to import them. And in this case, because I want you to have continuity between the ggplot implementation of the grammar of graphics and the plot9 implementation of ggplot, we're doing import star. Generally, you don't want to do this. Generally, you want to do things this way, but for the sake of ease for you, we're going to do it this way. So let's go ahead and let that run. When that's done, we will run this, and you'll notice that it's kind of waiting. This cell is, right? So, installing packages with pip. Let's talk a little bit about what it means to name a package like this. When we did things in R, we didn't really run into the problem of multiple libraries having the same name for a function. For example, mutate is really only a function in the dplyr library. ggplot is obviously only a function in the ggplot library, and so on and so forth. However, in Python, that's not necessarily true. There may be many libraries that use the word apply as a function. And what we're able to do in Python is to have this prefix before we use those functions to tell us what package is that function coming from. Now, sometimes this is a little bit redundant, right? Many libraries use names for their functions that are not repeated across different libraries, but in general, it's good practice to be able to do this sort of thing so that we can track what functions we're using out of which libraries. And as our code expands and we import 10, 20, maybe 30 different packages, we can go back through our code and we can say, actually, I don't see PD anywhere. It's not used anywhere in my code. So I'm just going to take this out, for example, right? So we're naming our package here, and you'll see this naming come in handy in this lab partially and in another lab too. In fact, why don't we import numpy as np? NumPy is a package that will help us do a lot of our vector calculations. Calling and naming packages. Okie doke. Okay, so we've installed our packages. We've called them with these couple of prefixes. So now we know we have pandas, we know we have NumPy, and we know we have plot9, which for our purposes are probably going to be the three main packages that we use when we use Python for this lecture anyway. So let's go ahead and let's save this. And let's save as. Go ahead and let's go to our lab and let's call this lab 7. Okie doke. When we want to read in data, we're going to just use read CSV as we did in R. However, we need to tell Python what package to use when looking for the read CSV function. So we're going to do that. And in fact, let's look in our working directory here for a second. We have the electricity data set that we've used before. So we're just going to read that in because I don't really care to do much analytics, in particular in this lab. We can always do that in the next lab. And this data set we know. So we know it lives here where we have saved our notebook already. We know the data set lives here, so let's go ahead and load that. So let's go back to this prefix. We know that anytime we use pandas, we're going to have to say PD. And I know that the read CSV function comes from the pandas package. So let's say PD dot read, and you'll notice that VS Code is telling me all of the different functions in pandas that start with read. There we go. We have read CSV right there. And we're going to do the same thing as we did in R. And we're just going to go ahead and we're going to run that. So let's see how this goes. So PD is not defined. So it looks like when I saved, it kind of stopped the kernel. So we're going to have to run that again, which is no problem. So let's just go ahead and run that library. Cell, we're going to run it again. And sure enough, we get our data set. This is exactly the data set that was in electricity. We should be very familiar with it by now. You may say, oh, actually, this is quite a nicely formatted data set. It's much prettier than the one that R prints out to its console, and you'd be right. But it's the exact same data, right? The presentation is a little bit different, but it's exactly the same. Notice that we use the same prefix when calling this function that we named it up here in our packages. And just as in R, Python is a object-oriented language, and so we can just assign that data to an object called data. Now you'll notice there's no environment variable here, or environment panel here, as there is in RStudio. And that kind of encourages and discourages different types of behaviors. It encourages you to write code that is very modular and does not have a whole ton of dependencies way earlier in your code, right? It's kind of asking you to use your memory to remember what objects you have created. Generally speaking, that means you're only going to create objects that you use right away, and then you're not going to keep referencing those objects way down the line in your code. Or you're just going to keep using the same object again and again and again. So The assign operator in Python, by the way, is the equals, one equals. We could use equal in R. We, or I, prefer to use the arrow, but it's all the same. It doesn't matter. So let's go ahead and let's insert another cell below. And let's call our object. And let's see what we get. Yep. So we loaded our package. We loaded our data. And then we printed out our data. At this point, the benefits of using an IPyNotebook may start to become clearer to you, though maybe not quite yet. You'll notice that the different parts of our code each go in their own cell. And it makes it much easier for you to follow the logic of what is happening at every step. Right? So we might say, okay, in this step we're kind of setting up. In this step, we're loading data. In this step, we're looking at our data. Now, it doesn't really make much of a difference now because this is not an enormous data set, but often you will find yourself working with data sets that are many millions of rows long, and it's going to take you a couple minutes for it to load into your environment. Alrighty, now that my neighbor is done pestering me, let's get back to it. So, as you noticed, each of the different concepts that you tackle whenever you write your code go in their own cells, and that way, for example, let's say you've loaded your data set and you want to do some calculation. You don't want to have to reload your data set every single time. Instead, you can just group your loading and your libraries code together. You can run them separately and then just rerun whatever analysis code that you're interested in, maybe your visualization code, other stuff like that. So terrific. So far, we've done a couple of things. We've read our data in much the same way that we read data into R, with the one exception that we had to tell Python what package our function came from. Now there's one or two things that are different about Python, although I think you'll find that most of the syntax is very similar to how R is written. So you'll notice this, for example, is not, completely foreign to you. It should look very similar to the same way that you loaded data in R is basically the way you load data in Python. Likewise for doing a lot of different things. If you want to look at a column, for example, one way to do that is not with the $sign operator, but instead we're going to open up square brackets and we're going to say, just show me what country looks like, right? This is pretty interpretable. However, one of the things that is different between Python and R is that Python uses methods in a way that R does not. What do I mean by that? Basically, anytime we wanted to do something in R, it took this form. We're going to say we want to do something, function, on some object. And inside those parentheses, we would put our data, and then maybe we would have an extra parameter. For example, we might say yes, drop NAs, things like that when we do some. Some objects in Python have built-in methods, that is to say common operations, that rather than calling the function on them, we can just call the method on that object directly. What does this mean? So let's take a look at our electricity data. Electricity data again. If we do dot, which is how you call a method, and we do mean, for example, you'll notice that it shows you the average of the electricity variable without having to do something like mean data electricity, right? I'm not sure that this would run anyway. It wouldn't. But this is how we would write that in R. Whoops. Electricity. Yep, there we go. Okay. This is how we would write this in R. This, in a sense, is a little bit easier to read. And in fact, the dot may remind you of the pipe. And in a sense, that is kind of what it is, right? So not everything is able to be done via method, but this array, and we'll get into what an array is in a little bit, the mean is a method that is built in. There are all kinds of other methods built in. For example, you can take the absolute value. I'm not sure that's a particularly useful aggregation here, but you can take the minimum and it'll show you what the smallest value is. You can take the maximum. Very cool. You can take the median. Basically, any of those functions that you would have put into a summarize function in R are, generally speaking, methods in Python. So terrific. Let's go ahead and just leave that here. And let's say some objects have methods that you can call instead of putting the whole object into a function. Some people like the way this looks, some people do not. One other thing to note about methods, is that they all start with a period. Whatever your object is, period, the method name. In R, the period was not a reserved character. When I say a reserved character, I mean that it is doing some programming function. It has a function outside of just being a character. For example, none of these individual letters are reserved characters. I can name an object data because the letter D is not a reserved character. That's totally fine. I cannot name an object period, for example, because period does something in Python. It calls a method. So a lot of the things that we see that we use periods for example, in R, you could name an object with a period. That is strongly discouraged and generally disallowed in Python. So something to keep in mind. What characters are allowed and which characters are not allowed in Python. Okie doke. Some of the object types that we're familiar with in R also exist in Python, albeit with different names. Now, in R, vectors cover both of these cases, although we didn't use it in the second type of case. But here, in Python, a vector is called a list. 2, 3, 4, 5. So let's just do that for now. Let's see what we get when we run that. Sure enough, this looks like R equivalent, something like 1, 2, 3, 4, 5, right? That's the R equivalent. No really further need for explanation there. This is called a list, and its R equivalent is a vector, right? You can put items in whatever order you want to. You can put in characters in there. A list can even hold another list. Whoops, I forgot to do that. And you'll see that that works that way, right? Terrific. Let's not worry too much about that right now, but let's just call this a list. The second type of object that we're going to use relatively often in Python is called a dictionary. It is very similar to a list, except that it takes the form key value. What does this mean? Let's say it looks something like that. We're going to say, actually, blue, orange, food, group, citrus. Key value pairs are the data structure that we use when we're using dictionaries. This is a dictionary. So, whoops, I'm going to say this is a dictionary. This is a list. So let's go ahead and let's assign citrus dictionary. Let's go ahead and assign that out to an object called whoops. I should slow down and spell correctly. When I call citrus dictionary, obviously I get this. But here's the thing, we can also call it by its key. When we call its key, we get a value. And if I'm to change this, if I were to look up its food group, I'll get citrus. So key value pairs are very handy because these are also kind of a building block of a data frame as we might use them in R. So I might say this is a data frame that contains lists. For example, I may do something like this. Aruba, Algeria, Armenia. And then I might say electricity, I don't know, 80%, 90%, 100%. And I'm going to assign this to an object called country dictionary. Sounds good. Let me go ahead and comment on this and say I can call values by referencing a dictionary's key. And then let's go ahead and take a look at our country dictionary. Interesting. So this is a data structure that's kind of a flattened version of a data frame. In the next lab, we're going to talk a little bit more about what's possible in a data frame. But let me tease that by just saying all we really need to do to turn this into a data frame is to call PD data frame on our dictionary. So let's go ahead and run that. And sure enough, it very easily puts it into a data frame format. So let's say country data frame, and there you go. So we can say I can make data frames out of dictionaries quite easily. There you go. So let's see what we've covered so far. We've done lists and dictionaries. Lists, as noted, are very similar to R vectors. Dictionaries are also similar to R vectors, so we didn't use them in this way when we were learning R, but at the end of the day, they're really just about key value pairs. Key value pairs. This is all we're doing right here. We're giving a name, and we're saying what value does that name take. We can also integrate both of these things into a dictionary where the key is the name of a column, for example. And then your values are, well, what are all the values that that key takes? What are all the different countries that you have? What are their values of electricity? Note that these are separated. Each key value pair is separated by a comma, and corresponding keys and values are separated by a colon. Terrific. So, as in R, Python is capable of arithmetic and all sorts of logical operations. Let's take our list and let's call it an integer list. Let's go ahead and just assign that. Let's take a look. Int list. Let's take a look at our vector or our list. We might call it a vector in R. It's a list in Python. And let's see what types of logical operations are possible. Let's do a real simple one. Say, is it bigger than 3? That's not really gonna work, is it? All right, so we'll notice that arithmetic and logical comparison are not really possible on generic arrays, or I'm sorry, generic lists. When we make a Python list, we can't do easily, or at least not as easily as in R, the type of arithmetic that we could do before. That's not to say that we can't do arithmetic. For example, Python is perfectly capable of doing something like this and making logical comparisons, right? So we get the correct arithmetic out, we get the right logical comparison out, but for whatever reason, a list, at least in its base form, is not capable of doing this type of arithmetic. What we need to do instead is change this into a NumPy array. So we're going to take our list, we're going to turn it into a NumPy array, and you'll notice that instead of just having the square brackets which indicate a list, it now says this is an array. Let's go ahead and let's try and add 3 to that. And sure enough, we've recovered the use case that we were doing in R, the functionality that we had in R. All I really want to do is element-wise operations on a list, and that's what NumPy helps us do. NumPy implements that functionality. So let's say NumPy arrays do operations element wise. Now let's say I don't want to call NP array every single time I do any sort of operation. All I have to do is just update my object type to an integer list, and then I can do any sort of operation that I want on it just like that. Addition, subtraction, division, logical comparison. So let's give a couple examples here. And let's say Python can do arithmetic and logical operations just like R. Great. All of the things that you have learned that are arithmetic and logical operations in R, Python can do as well, using pretty much the exact same notation. So I'm not really going to go too far into what is different, although I will say if you want to take a power, it is not caret, it's star star. So times, which is, you know, I guess kind of what an exponent is. It's times, but there you go. If you're trying to do this, that won't give you what you want. This will give you what you want. That's a bitwise operation versus taking an exponent. Okay, no, great. The last thing that we're going to cover is for loops. In R, our for loops looked something like this. Do XYZ. Or I'm sorry, print I. This is what our for loops look like in R. You'll notice for loops in R. You'll notice that there's a whole lot of doodads and baubles and trinkets hanging around here. You know, there's like an extra set of curly brackets that's kind of redundant and unnecessary. There's these brackets that are kind of unnecessary. You know, R is great at a lot of things. For loops is not one of them, right? The Python syntax, let's go ahead and comment that out. The Python syntax for loops is much simpler. For I, this is our temporary object, just as it was in R, into list, colon, print I. Whoops. That's it. So much cleaner, no need for these outer parentheses, no need for these curly brackets. All we really need is a colon to tell us what we're going to do, and the indentation is really important here. It tells us what level of iteration Python is working at. So we can say for loop in Python. There we go. So why don't we go ahead and restart our kernel here for a second, because I think it's always very good practice for us to restart and run our whole notebook from the start just to make sure that it runs properly. If you are worried about kind of the current state of your code, because you think when you run it again you'll lose a lot of the work that you've done, that's a good indication that you should go back and clean up your code so that it runs properly right from the start all the way down to the bottom. So this has been a super introductory glance at Python. In the next lab, we're going to talk about pandas. We're going to get back into the data frame manipulation that is really core to what you're going to do as a data analyst or a data scientist. But this was kind of necessary for a couple of reasons. One, the way that we load packages is a little bit different. you need to understand what those package prefixes do. But generally speaking, the syntax is very similar. You also needed to know what methods are. You needed to know that lists and dictionaries are different from each other, although in R, a vector kind of serves both purposes. So you needed to be familiar with how a dictionary works. You also needed to know what a NumPy array is, because if we want to do this element-wise arithmetic very easily, we need to change our lists into NumPy arrays. We also learned that arithmetic is very similar in Python as it is in R, with a minor difference for taking exponents. And then we looked at for loops very briefly. So this is all we're going to cover for today. Next time we're going to look more at pandas and look at all sorts of different manipulations that we can do. But for now, try and get familiar with these very basics of Python. It shouldn't be too difficult of a jump for you if you've been keeping up with the R stuff, and you may find that you like it a little bit more or a little bit less for different reasons. But what's important is that you try different programming languages, you try different tools. If you're early on in your career, it's way too soon for you to decide that you're only going to use one tool for your entire career and that's it, because that's a really quick and easy way to find yourself out of a job when the popular tool changes. So R and Python are different. They both have their benefits. Learn both, see which ones you like, see which one kind of jives with your personality a little bit more, see which one gives you the tools you need to do the job properly. All right, great job. See you next week.